Okay, in this video we're going to talk about section 7.2 in the book, which is going to be an introduction to factoring. Now on the notes page that you got, there are three types of factoring that we're going to look at. The GCF, or the greatest common factor, dots, or difference of two squares, and then trial and error with a equals 1 and a equals, or not equal 1. So the three types of factoring that we're going to look at are those. So let's start with the greatest common factor. When we're talking about greatest common factor, actually when we're talking about factoring at all, what we're really trying to do is the opposite of distributing. So before, when we would distribute, we'd have something outside parentheses and we would multiply it through the parentheses. Now we're going to do the exact opposite of that. So we're going to start with a problem, and then we're going to divide out something and then end up with parentheses. So if we look at example 1 under GCF, it says 4m squared plus 32. So if we're going to undo the distributive property, we have to figure out, what did I multiply each of these terms by? What do they have in common that I multiplied? So when we look at it, we can say, well, this term has a 4, this term has a 32, this term has an m squared, this term has no m's. So we have to think, is there a number that I multiplied something by to get 4 and something by to get 32? Well, the easiest thing to check first is 4. Can I divide a 4 by everything? What's 4 divided by 4? Well, 4 divided by 4 is going to be 1. 32 divided by 4 is going to give us 8. So instead of distributing, multiplying everything by 4, we're going to divide by 4. And we're going to put that outside of our parentheses. So 4 divided by 4 is going to give us 1 m squared. And then 32 divided by 4 is going to give us 8. So we're left with m squared plus 8 on the inside. So again, we're undoing the distributive property. We can check our answer to make sure we're right. If we were to distribute this 4 back into the problem, we should end up where we started. So again, distributive property is multiplying. Multiply that through. Factoring is really just dividing out. What can I divide each of these things by? So we can factor a 4 out of each of those. Now this works even if we have variables involved. So if we look at number 2, we get 4x squared times y to the third minus 2xy squared. So we're going to start with the same thing. We're going to look at the numbers. I have a 4, I have a 2. What can I divide each of those things by? Well, I can divide each of those by 2. This first term has an x squared. The second term has just an x. How many x's can I divide each of those by? Well, I can divide each of them just by x. Right? I can do x squared divided by x. I can do x divided by x. So we're going to take an x out. We can't take an x squared out because I can't do x divided by x squared. If we look at these, we have a y cubed, we have a y squared. I can't do y squared divided by y to the third, but I can do y squared, or y to the third divided by y squared. So I can divide out or factor out a y squared. Then we have to figure out what's left in the parentheses. So 4 divided by 2 is 2. X squared divided by x, so we're taking one of the x's out. We have 1 left over. Y cubed divided by y squared, if you think about it, we have y cubed over y squared. We have 1 left over, right? Because if we're dividing, we subtract our exponents. We're left with a y. Minus, because of the minus here. 2 divided by 2 is 1. X divided by x is 1, so we could write times 1 here if we wanted to. Y squared divided by y squared is 1. So we have 1 times 1 times 1, which is just 1. And again, if you wanted to check your work, take 2xy squared, distribute it through here, and you should end up at the right spot. Now, that's greatest common factor. That's something that you are going to want to check every single time in every problem, no matter what. See if you have a greatest common factor. So the next type of factoring that we're going to look at is going to be difference of squares. And we're just going to call that dots, difference of two squares. So if you look on your paper, it says a squared minus b squared is going to be equal to a plus b times a minus b. And actually your paper says minus b times plus b, but it doesn't matter the order in which you multiply. So the trick here is we want to look and see if we only have two terms, First, we're going to check for our greatest common factor. If we don't have one of those, or even if we do, the next thing we want to do is look at this term here. Can you take the square root of that number? Can you take the square root of that number? And if you can, what the square roots are going to be, in this case a and b, are going to be put into this set of parentheses. So if we look at number 4, we have x squared minus 100. So we got to look for a common factor first. The number here is 1, the number here is 100, so I could divide by 1, but that doesn't really help anything. We have an x squared here, there's no x's here, so I can't factor out any numbers, so there's no greatest common factor. So there's only 2 terms, so we got to think, can I take the square root of x squared? Sure, it's going to be x. Can we take the square root of 100? Yes, it's going to be 10. If you can do that, we now have a and b that we have written up here. So x squared minus 100 is going to be x plus 10 times x minus 10. So it's going to follow this pattern here, a plus b, a minus b, where a and b are the square roots of the terms that we have. So let's look at number 5. 5 starts out with 10b squared minus 90. Oh, not 900, just 90. So the first thing that we're going to want to look at is we're going to want to say, do we have a greatest common factor? So I have a 10 here, I have a 90 here. What can I divide these things by? Well, I can divide each one by 10. So I'm going to factor a 10 out. 10 divided by 10 is 1 b squared. 90 divided by 10 is going to be 9. So then we really want to focus just for now on the inside of those parentheses. We have 2 terms, so we have to say, can I take the square root of b squared? Yep, d. Can I take the square root of 9? Yep, it's going to be 3. So we have our a and our b here. So this is going to be d plus 3, d minus 3. But don't forget we had this 10 that we need to bring down front as well. So it's 10 times d plus 3, d minus 3. So if you have 2 terms, the first thing we want to look for is greatest common factor. Once we look at the greatest common factor, what we want to do is see if we can take the square root of the first piece and the square root of the second part. And if we can, we have difference of squares. If you can't take the square root of those, then you don't have difference of squares. So next thing we're going to look at is factoring trinomials. So factor using trial and error, a equals 1. So if we look at number 7, it starts out with x squared plus 9x plus 20. So first thing we always want to look for is greatest common factor. I have a 1, a 9, and a 20. I can't divide those numbers by the same thing. I have an x squared, an x, and no x's here. I can't divide all of those by the same thing. So we have no greatest common factor. If you have 3 terms, a trinomial, x squared, 9x, and 20, we want to think of this as ax squared plus bx plus c. The process for undoing our distributive property is to think about the product of a times c. We want to find out what numbers are going to multiply to give us a times c that are going to add to give us b. And that's going to come from undoing our distributive property. So if we look at this problem here, our a is 1, our b is 9, and our c is 20. So we want to think first about what is a times c. Well, a times c is 1 times 20. It's going to give us 20. So we want to think, all right, 20. What numbers can I multiply to get 20? Well, I can do 10 times 2. I can do 20 times 1. I can do 5 times 4. Then we have to think, out of all of these options, which ones are going to add up to our value of b? So b is 9. So 10 plus 2 is 12. So we don't want that one. 20 plus 1 is 21. We don't want that one. But 5 plus 4 is 9. So we want 5 plus 4 equals 9. Once we get our numbers, 5 and 4 in this case, we want to rewrite this 9 as 5 plus 4. So we have to think x squared plus 5x plus 4x plus 20. So if you think about if you had a distributive problem, you would do the distributive properties, so the first terms, then the outer terms, the inner terms, the last terms. You're always going to end up with 4 things, and then we would combine these like terms here to get 9. We're working backward. So once we get these 4 terms, we want to use greatest common factor in our first set and in our second set. So x squared and 5x, we don't have a number in common, but I can factor an x out. So that's going to give us x plus 5 for that first part. In the second part, I have a 4 and I have a 20. Well, we can divide each of those things by 4. So we divide by 4. 4 divided by 4 is 1x. 20 divided by 4 is 5. Now, if you do this correctly, what's left on the parentheses should be the same. So in this case, we have x plus 5. So if they're the same, we can think of those as the greatest common factor of our 2 terms. So if we factor out a greatest common factor of x plus 5, x times x plus 5 divided by x plus 5 is just going to be x. 4 times x plus 5 divided by x plus 5 is just going to be 4. And we're ending up here at x plus 5 times x plus 4 is going to be our answer. Alright, the last type of factoring we're going to do is actually the same type of stuff. If you look at number, we're going to go to 15. It says 20p squared plus 4p minus 24. Now, we want to start with a greatest common factor, see if we have that first. So 24 and 24, we can divide all of that stuff by 4. So we factor out a 4. 20 divided by 4 is 5p squared. 4 divided by 4 is 1p. 24 divided by 4 is going to give us a negative 6. Now the difference between this and the one we just had before is our a term. Remember, we want to think of this as a x squared plus bx plus c is not 1. In this case, it's 5. That's not going to change our process at all. So we still want to think about what is a times c. In this case, that is 5 times negative 6, which is going to give us negative 30. So we need to find our factors of negative 30 that are going to add to give us our b term. In this case is 1. So factors of negative 30, we can say negative 30 times 1, 30 times negative 1, 6 times negative 5, negative 6 times 5. And we can check those real quick, see if we're going to add up to 1. Negative 30 and 1 is going to be negative 29. We don't want that. 30 and negative 1 is going to give us positive 29. We don't want that. 6 and negative 5 is going to give us 1. That's what we want. So we want to rewrite p as 6 and negative 5. So we can say 5p squared plus 6p minus 5p plus 6. I'm sorry, minus 6. Right? We have minus 6 right there. Then we want to look at the first 2 terms, the last 2 terms, and find our greatest common factor. Well, 5 and 6 don't have any common factors, but they do. P squared and p are in common, so we can factor a p out and give us 5p plus 6. Negative 5 and negative 6 have a negative 1 in common, so we have 5p plus 6. Our parentheses are the same, so we're going to factor out the parentheses, and we're going to be left with p minus 1. So that's going to do it in this video. We will see you in the next video about factoring.